This is Note Taking Guide 3.1 for Mathematical Decision Making for Life. Today we're going to talk about something called a matrix. So what is a matrix? Matrix are an organized list of numbers in some way similar to a spreadsheet. So this matrix is called matrix A. It has rows and it has columns. The rows are the number that comes first in your matrix description. It's number of rows and then times by the number of columns. So the number of rows that this has is 3 rows by 2 columns. This would be called a 3 by 2 matrix. So let's state the dimensions of these other matrices and see what we get. So how many rows here? There's 1 row. How many columns? There's 4 columns. So this would be a 1 by 4 matrix. How many rows here? There's 2 rows. How many columns? 1, 2, 3. So this would be a 2 by 3 matrix. How many rows here? 3 rows. How many columns? 1. It's a 3 by 1 matrix. How many rows here? That would be 4. How many columns? 2. So this is a 4 by 2 matrix. So again, we state by rows and columns in our matrix. Each entry in the matrix is called an element. Elements are identified by naming the row and the column in which they appear. So here's matrix G, and this would be the element G 2, 1. 2 is going to represent the rows. 1 is going to represent the column. So I'm row 2, column 1. So in row 2, column 1, what number is that going to be? That's going to be the number 18. So again, I just counted down to where row 2 was. Row 2 was right here. Column 1 was right here. Where they overlapped was my answer, and my answer was right there, the number 18. So let's see if we can figure out the rows and columns here. So this is row 1, column 3. So you go row 1, column 3. The answer there for row 1, column 3 would be the number 8. And then we're just going to keep doing it again. So here's row 2, column 1. Here's row 2. Here's column 1. Where they intersect is the number 6. So my answer there is going to be the number 6. Next one is 3, 5. So row 3, column 5. So that will be a negative 8. Row 5, column 2. So when we're counting this, here's row 1, row 2, row 3, row 5. There's not, or I'm sorry, row 1, 2, 3, 4, 5. There's not a row 5. So this would actually be no solution. In math, when we do no solution, we can do that circle with that line through it, meaning no solution. The last one, row 4, column 3. So we're down 4 rows. 1, 2, 3, 4. So this one right here, column 3 would be 3 over. So we're at negative 2 for our solution there. So let's just use a matrix to kind of organize some data, because that's what matrices do. Matrices do is they organize data. So this is talking about a restaurant that's called Cardinmos King, and I'm just going to call it KK because that's a mouthful to say that. So it says when businesses deal with sales, there's a need to organize information. For instance, let's say KK is a fast food restaurant that made the following number of sales. On Monday, KK sold 35 hamburgers, 50 sodas, and 45 fries. On Tuesday, it sold 120 sodas, 56 fries, and 43 hamburgers. On Wednesday, it sold 15 fries, 12 hamburgers, and 19 sodas. To keep an inventory of this information, a programmer creates a matrix to hold this information. The information can be used to determine how much profit was made, how many items were used, and which days were most productive for the business. Let's build a matrix to represent this data. So I think I'm going to go hamburgers, sodas, and fries this direction because there's 3 things. And then I'm going to go Monday, Tuesday, Wednesday this direction, and then just fill in the matrix with my information. So on Monday up here in the top it says I had 35 hamburgers, 50 sodas, and 45 fries. On Tuesday, it was 120 hamburgers, 56 fries. Oh, hold on. I did that wrong. It was 120 sodas, 56 fries, 43 hamburgers. And then on Wednesday, it was 15 fries, 12 hamburgers, and 19 sodas. So what I've done now is created a matrix that represents all of that information that was up there in those paragraphs in one really nice, quick and easy way to look at the information. Another thing that we can do with information in a matrix is we can make digital images. So digital images are made by taking a picture of something. So say this picture right here. We lay a grid over the top of it. This is a 10 by 10 grid, which means it's going to be a 10 by 10 pixelated image, which is not really great as far as like what the image is going to look like. It's going to be grainy and you're going to see the digital part of it. But what we would do is we would take this image, lay the grid over top of it, give it a color scale to look at, and then we would draw the matrix right here to allow for every color in that color scale. So this first part of the matrix here, it says that its color shade here is 1. So that means that it was light like this. And they just filled in the matrix according to the picture when they put the grid over top of it. And then if you were to take this matrix and you were to recolor it yourself, it would show up something like this. So again, not very detailed, kind of grainy and ugly looking. How would we get that to look better? Well, we would do better than a 10 by 10 grid. When we take regular pictures now on a camera, we do 2048 by 2048 on our grid. So just so much more detail closer in on that picture, given every little spot and a little shaded zone and a huge matrix to look at. So if we were to change that to a grid that was 2048 by 2048, we would have so much more detail in this picture because we would be looking at littler chunks of it at one time. It says, if I wanted to lighten this matrix, what operation would I use? Well, if I wanted to go from a 7 to, say, a 4, wouldn't I just subtract that data in order to get it to be lighter? And if I wanted to do the opposite, which would be go from like a 2 to a 6, then I would have to slide to the right, which would be adding numbers to that scale in order to make it darker. So here's my grayscale here. 0, 1, 2, and 3. Use the grayscale to find a 6 by 6 matrix that digitally represents the image on this. So if you look at this spot right here, we're probably a 1, so we would put 1 inside our box. Clear like this is 0, so 1, 0. I think I'm going to go 1, 0, 1, 1 again. Then I'm going to go 0, 3, 0, 1, 2, 1. 1, 2, 0, 0, 3, 0, 1, 3, 2, 3, 2, 0, 0, 3, 0, 0, 2, 1. And 1, 2, 0, 1, 3, 1. So what I did was I used those numbers to represent the shaded areas that were inside the box. So I've created this matrix now for the picture that I've seen. So what do you think this picture is? It's kind of hard to see, but I think if I change the contrast on that, I could make it look better. So this next one says increase the contrast of an image. You would make the light areas lighter and the darker areas darker. So increase the contrast of the image we just did by changing each 1 to a 0 and each 2 to a 3 in the matrix. So instead of having 1, 0, 0, we would change the 1s to 0. So I would be on this top row here. I'd be 0, 0, 0, 0, 0, 0. So that's what we were going to put over here because all of our 1s changed to 0s. And then it said keep the 3s 3s, but it also said change the 2s to 3. So I'm going to go 0, 3, 0, 0, 3, 0. So 0, 3, 0, 0, 3, 0. contrast wise. I'm just going to keep flipping back and forth and doing that. So I'm going to go 0, 3, 0, 0, 3, 0 again. And then I'm taking this next row here, so 0, 3, 3, 3, 3, 0. 0, 3, 3, 3, 3, 0. Then 0, 3, 0, 0, 3, 0. And then the last one is going to be 0, 3, 0, 0, 3, 0, just one more time. So 0, 3, 0, 0, 3, 0. Now if I look at the contrast on that one now and I look at only the 3's and where they're at, I can tell exactly what that shape is. Now before I could kind of tell it was supposed to be an H, but now it's pretty obvious that it is an H. So contrast helps determine what the shape of the figure really is. Okay, so this one says draw the image represented by the matrix below. You can recognize what this is. If you don't, try increasing the contrast. So this is going to be hard for me to do with this, but what I'm going to try and do is just use some shades of gray here. So let's say I'm going to go through and do all of my ones because I have a shade of gray here that might work for. So here's a 1, here's a 1, here's a 1, and that's probably not a really great shade of gray to use for my ones. This will be lots easier with a pencil, not so easy on the iPad that I'm using right now to shade with. Okay, I'm going to go and try the darker shade of gray now, and I'm going to use all my number 2's for the darker shade of gray. So here's my 2's. And again, like I said, this is just kind of not going to look super great on mine because I'm kind of following along with on the iPad here. See if I got all the 2's. I think I did. I'm going to go change to the next shade of gray. And now I'm going to do my 3's, which is here and here and here, 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 and here. And here, and then it just says, can we tell what this is? And actually I can kind of tell what it is. I think that this is the letter E by looking at that, and clearly if I change the contrast on that again, I could get it to look better. But this is what we're going to be doing today on today's assignment, using matrices to identify things, and then using matrices to make digital images in order to, and also to organize data.